Hello Twitch, hello YouTube, hello Discord. We are tonight going to talk about Deploy to Compute Engine with a guide from the Google Cloud Platform website talking about a blue-green deployment. And we have Kat here in the audience on Discord. I'd like to invite you up to the stage to talk with me about blue-green deployment and Discord bots if you'd like to. Hello.
Hold on.
There you are.
Hello.
Welcome. Nice to have you on the stream.
Uh, Hello. What is this for?
This is for I feel like streaming, and I don't know if it was clear, but you're on YouTube and Twitch.
Okay, cool.
Okay, cool. This is for I was thinking about how do I want to be deploying the Discord bot, and what I've been doing so far is kind of a basic way of doing it. I log in, I copy the files over to a Google virtual machine, and what do I do then? I just log into the machine and basically type python main.py or bot.py, whichever it is. I think it's main.py. And I think it would be cool to have this whole thing automated. And on top of that, because I am sometimes kind of overly fastidious, I want to do it with as little downtime as possible when the bot updates to new code, for example.
Okay.
And I was searching ways to do that, and I came across this tutorial on the Google Cloud website about a blue-green deployment, which means that you have two systems up and running that are capable of being your bot, and you have a switch that sends traffic to one or the other, and you can control which one is live at any given time, and you can deploy code to the one that's not connected to the live internet and run tests on it if you need to, and then flip a switch, and then the other one. So if you were blue, then you become green. And if you were green,
Okay.
then you become blue.
Okay, I have a couple questions before you
Okay.
continue.
Yeah, go ahead.
Okay, first of all, the screen share quality is pixelated.
My recommendation is stay on the Discord audio call, but I'll actually stop sharing the screen since I got that feedback last time. I think it's a Discord limitation. I would recommend go to Twitch and watch the screen from there, but stay on the audio here. You can mute the audio from the Twitch stream.
Can you send a quick link to it?
Oh, sure. Yeah, let me just go to the //twitch.tv/Eric K_Anderson. Give you an so you can see it easily.
And then two, when you say Google VM, do you mean when you say Google VM,
Okay.
do you mean your VM or Google's cloud?
I mean a virtual machine, a virtual server on Google's cloud.
Okay.
Specifically, the Google Compute Engine is the name of the product.
Okay.
And it's a computer that lives up in the cloud. That's where the bot will be running. And I'll have two of those computers running, one for blue and one for green.
Okay. How will they communicate exactly? Or is that would they just do it themselves?
The two computers won't communicate with each other. And I believe the app's memory will live on MongoDB. So I won't need to have the two computers talking to each other at all.
Okay. Okay, continue.
Okay, so deploy to Compute Engine. It says this guide explains how to perform zero downtime blue/green deployments on Compute Engine managed instance groups using Cloud Build and Terraform. Instance is just another word for computer, virtual computer.
Yeah.
Cloud Builds enables you to automate a variety of developer processes, including building and deploying applications to various Google Cloud runtimes, such as Compute Engine, Google Kubernetes Engine, Anthos, and Cloud Functions. Of those, I've used Cloud Functions. I haven't used the other two, but it seems that from what I've read so far, when you have a long-running process that you never want to shut down, Google Compute Engine seems to be the way to go. And going on, Compute Engine MIGs, managed instance groups, enable you to operate applications on multiple identical virtual machines, VMs. You can make your workload scalable and highly available by taking advantage of automated MIG services, including auto scaling. I won't be using that. I'll be running this on one blue machine and one green machine at a time. Auto healing, that sounds fancy and important, but I don't know how it works. Regional multi-zone deployment, and automatic updating. Using the blue-green continuous deployment model, you will learn how to gradually transfer user traffic from one MIG blue to another MIG green, both of which are running in production. Oh, that's interesting that you gradually transfer traffic. This is way more advanced than anything I need, but I'm finding it interesting, so I'm glad I'm doing this.
Wait, if you have to do gradual transfer, does that mean? So I thought this was originally like if one happens to shut down, then all the traffic would just go to the other, and they would just flip back and forth. You know what I mean? Like a backup, basically.
Yeah, a backup.
This is not it.
I don't think this is so much of a backup that gets switched to automatically. I think this is more of two running computers, and you just trust them to keep working. But you manually push a button to switch it from one to the other. Or you do it on a scheduled timer, but I don't think that it responds to an outage on the blue end and to move it to the green end.
I don't entirely get the purpose of this then. Not yet, at least.
I think one of the purposes is you can update the green machine while the blue machine is doing the work.
Oh, you can manually set which one goes to which?
Yeah.
Like traffic?
Yeah.
So you can even turn off one of them, just use it as a testing ground.
Yeah, you could do that.
But it says both of which are running in production. Oh, that's just an example.
It says both are running in production. I think that means that both are set up so that they could accept, the full brunt of live traffic at any time.
Okay.
Except for when you're updating one of them. I think that's the concept. We'll see how it unfolds in this tutorial, and I think that'll help.
Yeah, we should
clarify
look at the design overview.
Yeah, design overview. The following diagram shows the blue-green deployment model used by the code sample described in this document. So we have users 1 sending traffic to a blue-green load balancer called Cloud Load Balancer. And 2 seems to be that it's currently going to the green VM pool. It says pool, but I expect I'll only be running one VM. Then a green load balancer, Cloud Load Balancer. I don't know why we need a load balancer behind the virtual machine. I imagine they'll talk about that. And then at 4, we have QA Dev, which is, I suppose, developers having access to the virtual machine through a load balancer.
Wait, okay. So I feel like this this diagram or design is very similar to something I know, but they just call it differently. So basically, if you're trying to get there's like a lot of people trying to get info from a website. What will happen for, I think, some providers, I can't remember, is that they would use like a load balancer to divide the traffic into different servers. Is this similar?
This is similar to that. I think the difference in this in this pattern is the concept of sending all the traffic to the green pool for a while and then flipping a switch and sending it all to the blue pool for a while.
Okay.
Whereas with what you're describing, I think all of the destinations are continuously on and traffic is trying to be smoothed out, in a balanced way to the different computers.
Yeah.
So it's a slightly different use case, but it uses the same tool in a load balancer.
I want to know the exact differences or detail, but it feels very similar.
So let's see what it says about this. At a high level, this model includes the following components: 2 compute engine pools, blue and green, 3 external HTTP, potentially S, load balancers, a blue-green load balancer that routes traffic from end users to either the blue or the green pool of VM instances, a blue load balancer that routes traffic from QA engineers and developers to the green VM instance pool, a green load balancer that routes traffic from QA engineers and developers to the blue instance pool. 2 sets of users: end users who have access to the blue-green load balancer, which points them to either the blue or the green instance pool, and QA engineers and developers who require access to both sets of pools for development and testing purposes. They can access both the blue and green load balancers, which routes them to the blue instance pool and the green instance pool, respectively. The blue and green VM pools are implemented as compute engine MIGs. That was a managed instance group. And external IP addresses are routed into the VMs using the MIG, are routed into the VMs in the MIG using external HTTPS load balancers. The code sample described in this document uses Terraform to configure this infrastructure. The following diagram illustrates the developer operations that happen in the deployment. We have a developer, and it looks like one is I'm confused about the directionality of this chart, and I'm wondering which part of it to read first, but maybe I'll read developer first. So developer points to the laptop and runs setup.sh, and that activates cloud build, which points to a cloud source repo with app source and configs. And meanwhile, the laptop, your developer laptop, points to our GitHub project, GitHub repo with app source and configs. Cloud build apparently is pointing to the GitHub Git, and red says bootstrapping. And I forget / don't exactly know what bootstrapping means in a computer setup context, but it has something to do with setting up the system. And meanwhile, GitOps means that the developer pushes code to the cloud source repo, and cloud build triggers something that looks like it does cloud build pipelines apply and cloud build pipelines destroy on infra/main.tf and infra/main.tf vars.
Arguably, all of this, I felt like I almost understood it, but the developer diagram is so confusing.
Yeah, this is a detailed diagram. Maybe the text will help explain this. In the diagram above, the red arrows represent the bootstrapping flow that occurs when you set up the deployment infrastructure for the first time, and the blue arrows represent the GitOps flow that occurs during every deployment. To set up this infrastructure, you run a setup script that starts the bootstrap process and sets up the components for the GitOps flow. The script executes a cloud build pipeline that performs the following operations: creates a repository in cloud source repositories named copy of GCP MIG sample, and copies the source code from the GitHub sample repository to the repository in cloud source repositories. So cloud source repositories is basically Google's version of GitHub.
Sure.
Creates 2 cloud build triggers named apply and destroy. It says, note, cloud build supports first-class integration with GitHub, GitLab, and Bitbucket. Cloud source repositories is used in this sample for demonstration purposes. The apply trigger is attached to a Terraform file named main.tf-vars in the cloud source repositories. This file contains the Terraform variables representing the blue and green load balancers.
Sure.
To set up the deployment, you update the variables in the main.tf-vars file. The apply trigger runs a cloud build pipeline that executes tf-apply and performs the following operations. Creates 2 compute engine MIGs, one for green and one for blue, 4 compute engine VM instances, 2 for the green MIG and 2 for the blue MIG. I might change that because I don't need 4 VM instances. The 3 load balancers, blue, green, and the splitter, and 3 public IP addresses. Then, prints out the IP addresses that you can use to see the deployed applications in the blue and the green instances. The destroy trigger is triggered manually to delete all the resources created by the apply trigger. Okay. I was thinking that the apply trigger was like the switch from blue to green, but no, the apply trigger is to build the whole setup.
No. Oh, there's no switching?
I think they'll talk about the switching later. Objectives. Use Cloud Build and Terraform to set up external HTTPS load balancers with Compute Engine VM instance group backends. Perform blue/green deployments on the VM instances. In this document, you will use the following billable components of Google Cloud: Compute Engine, Cloud Build, Cloud Source Repositories, Cloud Load Balancing. To generate a cost estimate based on your projected usage, use the pricing calculator. I'm going to stick to small instances and trust that the other ones won't be too significant, so I think I'll be okay.
Sure.
When you finish the tasks that are described in this document, you can avoid continued billing by deleting the resources that you created. For more, see cleanup. Before you begin, to run the commands on this page, set up the gcloud CLI in one of the following development environments: Cloud Shell or Local Shell. I will use Local Shell because I already have the gcloud CLI. And it says create or select a Google Cloud project. I'm going to create a new project so that I can easily delete all of this. Actually, no, I'll just use my current project because it's all tied to one Terraform file, so I can just do Terraform destroy and it'll all be gone in one, in one step.
Good.
Okay, so I'll make my terminal a little bigger and then make it a little smaller and bring it over here. Let me think about how I want to organize this. Okay. Change my mind. I will create a new project. I'm indecisive tonight. gcloud projects create blue green key smash.
I would not call this that, but
That's what?
I don't know why you're calling this blue green with a bunch of different numbers.
Well, I mean, because I figure blue green is already taken.
This is for you?
This is for me.
Is this project ID global?
Yeah.
Like it's not relative to. Oh, okay.
Yeah, project. I think project IDs are global. If I don't choose a globally unique name, it might give it might generate a unique ID. But if I give it a unique name, then the name will be the ID.
Sure.
Yeah, I think it's supposed to be globally unique. gcloud components update. I should do that eventually, but I'll do it tomorrow. Config set project. And I'm not going to try to type all those numbers again. Except it missed the 5. That's interesting. Oh, that's interesting. Um,
Nice.
yeah, I have a project named the Pipe Bunch. Now you know that. I need to go off stream for a second. Apparently, I set an environment variable in my Z shell config file.
Yeah.
This is way too small for stream. Okay, that's better. Make sure that building is enabled. I'm going to go off stream to do that real quick.
Have you tried using the workspaces?
The which workspaces?
I mean, just general workspaces.
Google Cloud workspaces?
Oh, I mean, like for your OS, for your monitor. Never mind.
Oh, workspaces like where it goes from there to there.
Yeah, yeah.
Sometimes I use them.
Remember that cool sound that was
Yeah, the
making?
swoosh, swoosh.
Yeah.
It sounded fast. I'll deal with that later. Where do I actually do it? There we go. Okay. Billing is set up for this account. Make sure billing is enabled for your Google Cloud project. Trying it out. Run the setup script from the Google Code sample repository. So we're going to do bash curl raw.github user content Google Cloud Platform cloud build samples main mig blue-green setup.sh. And actually, I'm going to take a look at this code before I run it, just to make sure I'm not doing anything too wild. So I go to set. I happen to have it open in another window, so I'll go to setup.sh. I think they're setting the colors, although I'm not totally sure about that.
Yeah, they are.
Echo. Those are what?
Terminal colors.
Those are terminal colors. Cool.
Escape codes.
Nice. Okay, let's bring this across so I can see it more easily. So started green setup. Echo, it's red, safe to rerun this script to recreate all resources. Checking GCP CLI tool is installed. Read only, explicit project ID equals $1. I think that's the first argument to the I don't know exactly how that works. Okay, yeah, explicit project ID equals $1. That would be the first command line argument to the script. And if it's empty, then it asks you to get a project ID. And then you are about to do these things. If explicit content equals yes, then echo that. Okay, that's fine. Function do with retry. Command equals $@ trying command. Eval command and echo success on first try. Echo waiting a few seconds to retrying command.
Sleek 10.
This what?
Okay. I just saw Sleek 10. That was fun.
Sleep terminal?
I just saw the Sleek 10 command. I thought it was fun.
Okay, sleep The
it was related to something I was looking at earlier,
okay,
where
gotcha.
some guy was like developing something for someone else, and then to simulate a load screen, he put it fully.
Hmm.
It was funny.
Okay.
Continue.
Echo, enabling required APIs, and whoever wrote this says some of these can be enabled later with Terraform, but I personally prefer to do all API enablement in one place with gcloud. Cloud services enable with the project ID, cloud build.google APIs, and other important APIs. Echo, adding cloud build to roles/editor. So giving cloud build permission to do stuff. Adding cloud build to role/source.admin. I assume that's for like source code. Echo, configuring bootstrap job. rm-rf, so they removing the file in case it was already there. Cat, arrow, EOT boot, go into bootstrap cloudbuild.yaml, tags, mig blue green bootstrapping, steps, create new cloud source repo, okay. Recreating source code repository, gcloud source repos delete copy of blue green quiet true, gcloud source repos delete copy of mig blue green quiet. I guess it's deleting the repos in case you already had them there, clearing the path. And id copy demo source into new cloud source repo, gcr.io cloud builders gcloud with project ID and project number. I don't know where project number came from. Read only get repo equals a certain area. Cloning, or we're making good progress with this script. Cloning demo source repo, cloning new empty repo, making a copy, setting git identity, commit and push, add pipeline triggers, recreating destroy trigger, recreating apply trigger, EOT boot, waiting API enablement propagation, executing bootstrap job bootstrap.cloudbuild.yaml, no source, no user output enabled quiet. Echo, green all done. You can manually run apply and destroy triggers to manage deployment lifecycle. Green, few key links. Dashboard, console.cloud.go dashboard project equal project ID. And now it says green completed. What about blue? Or is green a variable that means something else?
Green is the skip color.
Oh, it's the color. It's not about the blue-green deployment. It's about green to make it look nice on my screen when I run this. Oh, okay. Okay, now I'm ready to... I've read the script. I know what it's doing. I can copy the command from over here and give it a run. Whoa.
Oh my god.
My video connection kind of freaked out. Sorry about that. Oh my gosh, this is not pretty.
What the fuck?
Yeah, I'm going to take this off of my screen. I think the refresh rate on the terminal was not playing nice with my capture card on my PC. So I'm just going to describe. You are about to modify project, enable various
Just feel like the
GCP
bottom,
APIs.
I guess. Feel like
This
the
what?
bottom of it. I feel like the bottom of it.
You feel like the bottom
Or
of
maybe
it?
you can't.
What about the bottom?
We only need the bottom most, right?
The bottom most of the script. I mean, of the terminal.
Yeah.
I guess, but I don't want to leave it on the screen when it's flickering crazy like that on the screen. So I'm just going to run it over here, and then the next part I'll show what's going on. So I'll enter yes.
Just spam enter. To be honest.
Just what?
Just spam enter. Do his Google script. There's no way. There's nothing wrong with the script.
Let's try this again. All right, receive user consent, enabling required APIs.
Yes.
Oh, this is going to execute the cloud build and Terraform plans via for VMs. Well, that's okay. I won't leave them on long. So it's waiting while
Oh, it's working right now. Okay.
it's working on it. Yeah, it's doing the thing.
I love it when these terminal scripts do this. And they just leave you hanging.
They just leave you hanging there, and you just have to wait. Just wait.
Not even like a loading bar. It's like a progress bar.
Well, I think it might be hard for them to keep track of how much progress has gone by or needs to be done. Maybe I don't know how that works.
How many APIs would it require? I forgot.
There was cloud build. There was. I mean, I could open the script in my browser and see.
Yeah, just give me real quick.
Come on, window. There we go. Oh, there it goes. It did something as soon as I stopped looking. Waiting, API enablement propagation, executing bootstrap job. Your current Google Cloud version is such and such, installing components from version such and such. These components will be installed. G-Cloud beta commands. That's interesting. Yes, I want to continue. Creating update staging area.
Okay, you didn't have to do this. This is someone had fun writing this script.
Mm-hmm. Installing cloud. Oh, this is the installation of the cloud beta commands, whatever those are. Performing post-processing steps, and it's got a little dancing thing there.
I thought
That's
this
nice.
script was made by several people.
Could be. And I think the script probably called other scripts at this point where we're installing things.
Yeah, but this was written all at once. Well, it didn't like fetch new info to like load these graphics.
Huh. Restarting command, gcloud beta build submit project config, no source, no user output enabled, quiet. I imagine if it wasn't quiet, it would be spamming lots of lines of output. Hello, Sammy Cat. Hey, completed. All done. Now you can manually run, apply, and destroy triggers to manage deployment lifecycle. Commit change to infra/main.tfrs and see apply pipeline automatically trigger. A few key links, dashboard, repo, cloud build triggers, cloud build history. Okay.
Wait, does the billing start now?
I think it's unclear to me whether the billing starts now or when I manually run apply.
Okay.
And to figure that out, I can look at the part of this where it says apply. Recreating apply trigger.
This is the script. You'd run this outside of the script now because it's done.
Yes, this is the script. I'm just curious. I'm just looking for. It looks like I created the
looking for
triggers.
the-
I'm just curious what it did and didn't do. And I believe it did create the triggers, but it did not trigger the triggers, if that makes sense.
Yep.
Manually run apply and destroy triggers, but how do I do that? Let's look back to this thing.
Or like G Cloud trigger or apply.
Maybe
Bad.
In the Google Cloud console, open the Cloud build history page. And from there, click on the latest build. You can see the build details page, which shows a cloud build pipeline with 3 build stages. The first build step creates a repository in cloud source repositories. The second step clones the contents of the sample repository in GitHub to cloud source repositories. And the third step adds 2 build triggers. So we'll look at the build history, build number, whatever, and lots of output. 0. Entity not found. Maybe it looks like it created. It wasn't found, so then it created the repository. Okay. Copy demo source code into new source repo. Add pipeline triggers. Okay, that all seems fine. Open cloud source repositories. From the repositories list, click copy of GCP MIG sample. Project ID blue-green, copy of MIG blue-green. Maybe I should zoom in a little bit. Files and directories, readme.md, setup.sh, teardown.sh, infra, lib, pipelines, testing. In the history tab at the bottom of the page, you'll see one commit with the description, a copy of such and such URL, made by Cloud Build to create a repository named copy of GCP MIG sample. Scroll down to the, where's the history? It's right here. Oh, and then there it goes. Now it's back. Cloud Build, date, a copy of that. Sure. Open the Cloud Build triggers page. You'll see 2 build triggers named apply and destroy. The apply trigger is attached to the infra/main.tfvars file in the main branch. The trigger is executed anytime the file is updated. The destroy trigger is a manual trigger. So we have the apply repository event push to branch. I wonder if it's a specific branch. Let's click on the apply one. Push to a branch. It doesn't say whether it's a specific branch. Oh, branch master. Yeah, it does say that. Okay, that's cool. Oh wait, let's go back to the triggers. And destroy says manual invocation. I bet there's a run button somewhere. Well, it says run on schedule, disable, delete. I don't know where the run button is. Oh, there's the run button. The trigger is attached to the infra/main.tfvars file in the main branch. So let's go back to the repository, MIG blue-green, infra main.tfvars. And let's see which color they start with. MIG version blue is V1, MIG version green is V1, and MIG active color is blue. So they start with blue. Fair enough. Okay. To start the process, update the infra/main.tfvars file in your terminal, create and navigate into a folder named deploy compute engine. Deploy compute engine. So I'm going to cd workspace, tmp, mkdir, what did they call it? Deploy compute engine. Wait, does it have to be in my root directory? I don't think so.
You can't make directory twice.
Oh, oops, thanks. Okay. Clone the gcloud source repos clone copy of MIG blue-green. And then cd./copy of MIG blue-green. Oh, on the master branch. That's old school. Update infra/main.tfvars to replace blue with green. I was looking at this earlier today. I'm not very familiar with the sed command. But
Never seen in my life.
Well, let's just do MAN-SED. SED, Stream Editor. The SED utility reads the specified files, or the standard input if no files are specified, modifying the input as specified by a list of commands. The input is then written to the standard output. And we can kind of piece together some breadcrumbs here. We have, I don't know what the -I is or the empty string, but the -E reminds me of what we saw. Oh no, I don't know what it reminds me of. S/blue/green G. And I think it's swapping blue for green is the idea.
I have no idea.
Well, let's just cat infra / main.tf bars, and let's paste this command and cat main.tf vars. What? Oh, cat infra / main.tf vars. And it was blue, but now it's green.
Okay.
Add the updated file, git add dot. Commit the file, git commit -m promote green.
Can you swap back?
Yeah,
Swap back the colors from green to blue?
I can.
Can you retype the same command to do it?
I think so, yeah. Let me try it. I won't commit it, but I'll try it. So it's green, and now I hit it and I cat again. Oh, it's still green. Oh, it's probably just a command to replace blue with green.
You probably just swap the variables.
If I, oops,
You just swapped it.
oops. Let me try this again. SED, if I go now and say green lowercase for blue, then I cat that. It should go back to blue. Yeah, there it goes. And now back again. Okay, and now the Git repository, the working tree is clean. Push the file, git push. I think this is the part where billing for the VMs will turn on. Making changes to infra.tfvars triggers the execution of the apply trigger, which starts the deployment. Open cloud source repositories. From the repositories list, click copy of GCP MIG sample. You'll see the commit history. You'll see oh, there's the cat. Yay. You'll see the commit.
Cat cam.
Yeah, it's now a cat cam. Oh, it's time to switch the timer over. Thank you for appearing on the cat cam, Sandy. You'll see the commit with the description promote green in the history tab at the bottom of the page. Click on this, history, and there's author Eric Anderson, promote green. Good. To view the execution of the apply trigger, open the build history page in the Google Cloud Console. Open the build history page. What a nice big blue button. And it's building from that source.
And you only did git push?
I only did git push. That's the whole point of GitOps, is you do a git push and everything else just happens.
Interesting.
And
in this case, you could also just have a dev branch, right? And then whenever you push to actual main, it'll build for deployment.
Yes. That's exactly how it would work. Because it's only triggering off of the main branch.
Yeah.
And for interest, we can now also look at infra main.tf, and this will have some of the things that it's building. So we have project, we have provider Google, we have variable NS1, the namespace used for all resources in this plan. Oh, that's interesting. Variable MIG version blue, version tag for the blue deployment and green version tag for the green deployment. We have the active color. We have module splitter load balancer. And the source for that is .splitter. And it has an active color. Let's see how this build is going. It's doing some more things. Cloud build, blue-green instantiation, module blue, ./MIG, Google Compute Network, Google Compute Subnetwork, Google Compute Subnetwork proxy only, module green, has the same things, and cloud build, blue-green instantiation. And the source for that was .MIG. So let's take a look at the splitter first, main.tf, and it has a bunch of variables, and it has a bunch of locals, and it has compute network, compute subnetwork, proxy only, lots of different things, firewall, allow proxy, ingress, Google Compute region health check, Google Compute region backend service, all kinds of stuff in here. Wow. Google Compute forwarding rule, Google Compute address active. How further does this go? Not much further. Okay, that's that one. That's the splitter. Now the managed instance group is probably going to contain the virtual machines and the individual load balancers. We've got locals. We've got cloud build, compute instance template. How big is this instance? It's an N1 standard. Yeah, I don't want to be running this overnight, definitely. Region US West 1, tags load balancer backend. And does it say which color it is? I guess this script doesn't need to know the color. And it's got health checks and some other stuff. Okay, let's see how the build is doing. Oh, it's done. Open the build details page by clicking on the first build. I did that. You will see the apply trigger pipeline with 2 build steps. The first build step executes Terraform apply to create the compute engine and load balancing resources for the deployment. The second build step prints out the IP address where you can see the application running. Open the IP address corresponding to the green MIG in a browser. You'll see a screenshot similar to the following showing the deployment. Open the IP address corresponding to the green MIG in a browser. Active color MIG is here, blue color MIG is here, green color MIG is here. Let's go at the green color MIG. Hey, it works.
Okay.
And I'm curious which VM it picks between the two. If I refresh this, does it always load the same one? Hey, it loads the other one. That's interesting.
Very good. It's like spamming, I guess.
Like spamming the refreshes.
Yeah.
Yeah.
I just wanted to see if it's even out.
Oh, if it's like the same, if it's about the same as of either one.
Yeah.
Yeah, it looks pretty even.
It's very similar to like a
Actually,
standard
it's
load balancer.
it's going predictably back and forth now if I do
Yeah.
it quickly.
It's like a standard load balancer.
Okay, cool. Go to the Compute Engine instance group page to see the blue and green instance groups. Open the instance group page. Here's the NS blue group manager, and here's the green group manager. Open the VM instances page to see the 4 VM instances. We've got blue VM, we've got blue VM other thing, we've got green VM, we've got green VM other thing, and these LT8B and R7H8 I recognize from the page over here.
Yep.
Open the external IP addresses page to see the 3 load balancers. We've got blue address name, we've got green address name, and splitter address name. Now, which of these ones am I going here? 204, 224. Okay, this is the green address name. This is for always accessing the green one. What if I access the splitter? It should, which one did we promote? I promoted green, so this should go green. And it does. and it goes back and forth between the two machines.
Okay.
That's pretty cool.
And if this is filled for some reason, it'll go to the blue.
If this is what?
Filled, the green pool.
If the green pool failed, it would keep sending traffic to the green pool no matter what until I manually change the file to promote the blue group.
Oh,
Yeah, kind of a bummer. I mean, I could write code to watch the green group and if it goes down, do something to promote the blue group, but by default, it doesn't do that.
do that by default.
Source code for this code sample includes source code related to the setup script, source code related to the cloud build templates, source code related to the Terraform templates. Startup script. Let's see how long this is. It's going to talk about this for a while, and I think I'm going to do Terraform destroy to shut down all the resources, so I'm not, because I don't need to be getting build for it while I'm reading carefully this. Cloud build pipelines. This is a lot of information. I might skip ahead to Terraform templates. I looked at some of this stuff already. Cleanup. To avoid incurring charges to your Google Cloud account for the resources used in this tutorial, either delete the project that contains the resources or keep the project and delete the individual resources. Delete the individual resources. Delete the compute engine resources created by the apply trigger. Open the cloud build triggers page. In the triggers table, locate the row corresponding to the destroy trigger and click run. When the trigger completes execution, the resources created by the apply trigger are deleted. Then, delete the resources created during bootstrapping by running the following command in your terminal window. And this is the teardown.sh. Then delete the project. Caution, deleting a project has the following effects. Everything in the project ID is deleted. Custom project IDs are lost. When you create this project, you might have created a custom project ID that you want to use in the future. To preserve the URLs that use the project ID, such as an appspot.com URL, delete the selected resources inside the project instead of deleting the whole project. That's another reason I did a key smash, is I didn't want to burn a project ID that I might want to use in the future, although I don't think I'll ever really need a blue-green project. But anyway, delete a Google Cloud project. What's next? Learn more about build triggers, learn how to view build provenance. What I would like to do is go to this open triggers page. Actually, what I want to do now is I want to go to my script here and cat infra main.tfrs. It's currently green, so let's do the sed command that goes from green to blue. Git add dot, git commit -m, promote blue, and git push. It'll happen any moment now. There it goes. Now I need to figure out which of these. I think build details is where I want. Go back to builds. Build history. Here it is, building a new thing. And the question is, will this one be quicker because it doesn't have to change as much? Run Terraform apply. It's apparently needs to install some stuff to be able to do Terraform apply. Your version of Terraform is out of date. Oh my. Initializing provider plugins. So it looks like it has to install Terraform on a virtual machine for this thing to happen.
That goes out of date and just installed it.
It probably does go out of date quickly. Plan 0 to add, 1 to change, 0 to destroy. So I expect this will go a little quicker. Let's see, which of these IPs was the load balance, was the splitter? This is the splitter. So currently, oh, we're already on blue.
Is it still building?
It's probably very near done.
Oh.
Now it says good luck. So yeah, the switch flipped before the build script finished. So that was kind of fun watching it turn from green to blue. I liked that. But I don't have any reason to keep all these 4 virtual machines running, so I'm immediately going to go back to the instructions to the destroy trigger and click run. Destroy. Oh, I need to go back and click the run button. Run trigger. Build started on branch master. Show. So it's doing all of these things. And if I go here, I see that it's up for a while. It's switching back and forth between the two virtual machines. If I go back to here, oops, maybe here, that's the one. This is the one I'm looking at. Okay, it's still working. Plan 0 to add, 0 to change, 27 to destroy. I can't believe it's 27 resources. That's so much stuff.
Can you look inside one of the other VMs real quick?
On its page, on this page.
Oh, just inside like the project, because you know how it's loading this URL, and we should be able to change it.
Inside of the VMs. What do you mean by inside of the VMs?
But you should be able to change the contents, right? To make it show something else.
Oh yeah,
page.
like I could SSH into the machine and do that. Yeah, I could, but it's probably half destroyed by now, so it's too late.
No, I meant the other ones, since you only destroy one of them at a time.
The other VMs.
This the entire thing.
This destroy is destroying the whole thing.
Oh, what the?
Because I saw the green and I saw the blue and I saw the green switch to blue, or maybe the other way around, and that was all I wanted to do with this. The next thing that I want to do with this is copy the code into my bot repository and cut it down to one instance per managed instance group, and make it a smaller instance so the billing is not as much, and then deploy the bot code onto it.
Okay.
It says it's still destroying something.
I kind of forgot that this was destroying the entire thing. I thought it was just destroying one of them.
That
kind of a weird button to have, actually.
Well, I mean, it's important to be able to destroy resources if you don't want to keep paying for them.
I mean, couldn't you like just slowly delete all of them, or like I don't know, have like a delete project button like somewhere else instead of like only having two triggers? One of them starts it and one of them deletes the entire thing.
I don't know where else you would put the trigger though.
Settings, I guess.
Maybe.
Then the destroy would just delete the whichever. I guess even like full maybe. You can delete the full, like one of them.
You could. I mean, if I changed the code manually, I could delete only one of them if I wanted to.
Yeah.
That would definitely be possible. And I'm guessing that the site can't be reached, so there's no more website.
Okay.
This one appears to still be showing, but I think that's
gone.
I think that's just oh no,
look, refresh it.
It's still spinning. It's trying to find it. It's not going to. So those are gone.
If you hard refresh it, it won't appear.
Yeah. Build details. This one. So still destroying. It's working on that. So what I'm gonna do is go to MIG blue green. Is it possible to download only this one directory? No, it's not. So instead, I guess I'll just clone the whole repository. How big is it? I don't know if it says here. Let's see, we're going to go to workspace, github.com, make directory Google Cloud Platform. Git clone this whole thing. Now cd cloud build samples, and then where do I want to go? MIG blue green, cd MIG blue green. And I'm going to be copying this into, let me think, copy, actually ls-a, let me see if there's any, oh, there's no hidden files, so that's fine. cp-r star into home, workspace, GitHub, ekand, except I'm going to need to make a new directory. To make directory, home, workspace, GitHub, ekand. Oh no, I want to put this in bot2. So I'm going to make a directory called, I don't know, maybe I'll call it infra, or should I call it blue green, or what? Naming stuff is hard.
Blue green keyboard smash?
I don't need the keyboard smash this time. I'll just do blue green. Copy recursive star workspace GitHub ekand bot 2 blue green, and cd workspace GitHub ekand bot 2, and let's open this up in PyCharm. I'm already in, don't ask again, I'm already in PyCharm. That's convenient. I'm going to close all these windows in case there's a .env open, which there was. Let's look at blue-green. And the first thing I'm going to do is look at the infra files. I think the splitter is probably okay, but maybe I can take out some of the stuff and maybe I can have a less beefy splitter. I don't know if this is let me see. Is it LB or load lobe? Rotates load balance backend. Yeah, I don't know how any of that works, but let's look in here to Google Cloud Compute Instance Template, name local L7XLB backend template, source image is persistent disk 0 read write, persistent labels true, machine types. Gonna change this. Oh, this is interesting. Bin bash sudo apt-get update, install Apache, sudo a2 and site default SSL. Oh, so it's setting up an SSL certificate. That's interesting. Echo the background color var.color. Nice. So you got the blue color or the green color. Hello world, app version, namespace, and VM hostname. Cool.
Let's do this. Edit this. That's direct to.
That's what?
You can just direct this to the other one. Let's replace it.
Direct what to the other one?
Can you direct the Python 3 index apart?
Python 3.
Did you put that in here, or is it just example
Did I put what in where?
here?
Bot2 Py3 over here.
Oh, this is just. Okay, never mind.
This is my Bot2 project in PyCharm. So stuff you're seeing might be related to the Bot2 repository.
No, I meant, would you replace this since you copied the blue green into here?
Yeah, I would eventually replace this with something
Yeah.
relevant to Python and probably poetry. Exactly. Yeah. Good point.
I wasn't sure if this was just a template. It says main, so I just assumed.
Um, just a
There's nothing
template.
else in here, so
This is the Terraform file that describes the managed instance group. Target size 1. And I'm going to choose a smaller machine because I don't need a big machine at all. I don't even need a standard machine. I just want a micro. And one standard. There we go. So let's go back to Chrome. Let's go to Google Cloud, create a VM, and look at what's the smallest one I can get. That's the one I want for this. This is...
I don't know why that's showing up.
Yeah, a lot of stuff is showing up that I don't need right now.
Low cost day-to-day computing. What were we using before? N1, right?
We're using N1. N1, balanced price and performance. Low cost day-to-day computing will work just fine. Standard. Here we go. Preset. Shared core E2 micro. Estimate $7 a month. Not bad.
Maybe advanced config. You can change it even more.
I can try.
Not sure this is James price.
Custom cores. No, you can't. Or wait, shared core. Yes, you can. Take it all the way down. Take this all the way down. No, the custom is bigger than the preset.
That's crazy.
Well, I mean, it's like doing things. It's cheaper to do things at scale. So if they do it,
Yeah, I know.
So that's probably why. Preset E2 micro. Why is it not good? Anyway, E2-micro is what I want. Gonna go to PyCharm C E2-micro. And then I want to think about how do I get the bot running on here? Because there are some details to that.
Oh, you'd probably have to install. Yeah, you probably have to install all of the dependencies, right?
Right. Yeah. So let's do this.
So we have to do sudo update.
Actually, we should probably do sudo apt-get update anyway. And I wonder about putting the Discord bot behind a load balancer. How do I get it to listen? Maybe it figures that maybe it automatically listens at the correct port and everything, but I don't know if that's the case. One thing I know about Google VMs is if I tell apt-get to install Python, it can only go up to version 3.9. But for interactions.py, I happen to need 3.10.
That's a little bit awkward.
It's a little awkward, but there's something called pyenv that allows you to get around this. So I'm going to look up the installation instructions for pyenv. Cancel this. Let me actually look at the equivalent code just to make sure that I. Oh, it's my phone tells me it's time to wind down. Type E2-micro. That's right. Okay. Pyenv in INCALL.
This is probably a good stopping point.
Good stopping point for the night. Yeah, you might be right. Maybe it is time for me to stop. Honestly, I am going to keep working on stuff, but I might get off stream just to...
3,000 commits.
Yeah, that's crazy. Pull request number 2752.
it's a funny thing for my private repos. I basically use commits as like just my save.
Uh-huh.
So some of my things have like 200 commits in
Nice.
like a week. So
Imagine how many commits have been squashed and are like hiding behind.
it's probably like 30,000 or something.
Yeah, it's probably a crazy big number. Yeah, I could call the stream here. That actually sounds okay. We got through the main part of it, and maybe I want to keep going. I'm gonna go to a stream break. It's been long enough to do that,
Sure.
and you can take off if you need to or if you want to.
Uh, I just joined it to see what was happening, but I'm gonna go back to what I was doing.
Okay, cool. Have a good night. Thanks for stopping by. Oops, I didn't do that right. It's wrong on two counts. I want be right back, and I want to have it say thanks for watching. Be right back. There it is. That's better. Oh yeah, you do want to come. You do want to hop back in. Okay, I'll let you back in.
Wait, I
Welcome,
just forgot.
welcome back.
I'm gonna share my screen real quick because I've been trying to solve this problem. So I've been trying to solve this problem for multiple days on Linux, and I couldn't get it working on Linux. So I just said, "Fuck it! I'm just gonna write this entire thing in Windows." I wrote the entire thing in Windows. I got it working in Windows, and
Okay.
I'm trying to move it back to Linux so I can like get the SQL thing working.
Okay,
Oh
yeah.
my god, I'm going
Hold on for a
crazy.
second, and then yeah, let me just do one thing. Oh, sorry, Twitch, I was muted, but I'm saying hello, goodbye, Twitch. Have a good night, viewers.